Welcome back to the channel. In our last lesson, we dealt with how to find the equation of a straight line. We saw how to find the gradient of the line and also treated special cases such as when we have two lines in parallel or perpendicular or the same axis. This will form the basis for our lesson today. In our lesson today, we will see how to find the equation of tangent and normal to a curve. In case you missed our last lesson, please do not hesitate to check the description below. We have placed a link to the last lesson in our description below. That said, let's get started. We'll start by defining the tangent. The tangent is a line that touches a curve at a specific point. In this figure, if you look at line PQ touches this curve at this point without crossing the point. Now, there is a unique characteristic between the curve and the line. At this point, we can find the gradient of this curve, and at this same point, we can find the gradient of this line. So, we'll use the concept of the gradient to now define the equation of a tangent. Now, the gradient of a line, also known as the slope of the line, we say is equals to a change in y over a change in x, which is the same thing as saying I'm finding the derivative dy dx of that line. Now, if this line is defined as y is equals to f of x, the gradient of this line will the derivative of y will be the dy dx, which is equals to f prime of x. Now, we can find the gradient of this line at a point by finding the derivative of this line at this specific point. And with that knowledge, we'll be able to define the equation of its tangent. Now, let's understand what the normal is to the curve. The normal is the perpendicular line to the tangent. Line QR, if you look at it carefully, is perpendicular to line PS. And line QR is the normal to this tangent. Now, the unique thing, because they are both perpendicular lines, like we stated in our last lesson, the gradient or the slope, let's call the slope of line PS, let's call it M1, and let's call the slope of line QR, let's call it M2. The slope of both lines, M2 multiplied by M1, will equals minus 1. We can use this basis to define the equation for this line QR. Now, let's take an example to further illustrate it. Now, our question says, find the equation of the tangent and normal to the curve y is equals to. Now, let's take a little sketch. Now, I'll assume that here is the curve and here is probably the tangent. Is touching the curve at this point. Now, this tangent, definitely we've been told it has a normal that is perpendicular to it. Now, this curve is defined by this equation, y is equals to 2x raised to power 3 plus 3. Oh, the tangent is at 3x squared minus 2x minus 3. So the tangent is at the point P. Okay, let's say here is the point P. The point P is at x is equals to 1, x is equals to 1, and y is equals to 0. So it's on the x-axis. Now, let's see. For me to define the tangent of this line, the first thing is to find the derivative of y is equals to 2x raised to power 3 plus 3x squared minus 2x minus 3. So that dy dx will be equals to 2. The derivative of 2x raised to power 3 becomes 2 times 3. That's 6. X raised to power 3, x minus 3 minus 1, that's 2. Plus 2 times 3 again, that's 6. X minus 2. Now my 3 becomes 0. Remember that we said in finding derivative of a line, if y is equals to ax raised to power n, then the derivative will be given as dy dx equals a nx raised to power n minus 1. This is what we have applied in here. We have also placed a link to the description below to show how to find derivative of a line, the derivative of an equation. And if you have gray areas, you have questions, please kindly use the comment section. We'll be there to respond to you. Now, I have gotten the derivative of this line. So the next thing is to find the point at which my tangent lies. My tangent lies at point x is equals to 1. So I'm looking for the derivative dy dx at x is equals to 1. Now this is equals to, when x is equals to 1, I have 1 plus 6 minus 2. That's equals to 6 plus 6, that's 12. Sorry, that's 12 minus 2, which is equals to 10. So my dy dx is equals to 10. If my dy dx, remember, if my dy dx is equals to 10 at the point P defined as 1 and 0, then I can now use my formula for the equation of a straight line, 1 minus y1 all over x minus x1 to be equals to m. So that my y now minus y1 here is 0 over x minus x1 here is 1 is equals to 10. Y now will be equals to 10 into x minus 1. So that y is equals to 10x minus 10. Now this is the equation of my tangent. This is the equation of my tangent. Now let's look for the equation of the normal. To solve for the equation of the normal, remember that both lines are perpendicular lines. So that m1, m2 is equals to minus 1. Now, my m1 is 10. My m2 is equals times m2 is equals to minus 1. My m2 will be equals to minus 1 over 10. Now, same equation. Y minus 0 over x minus 1 is equals to minus 1 over 10. Y over x minus 1 is equals to minus 1 over 10. So that's 10y is equals to minus 1 into x minus 1. 10y is equals to minus x plus 1. So that 10y now will be equals to minus x plus 1. Y is equals to minus 1 over 10x plus 1 over 10. You can obviously rearrange. With this, we have been able to define the equation for the normal, and also we've defined the equation for the tangent. Like I said earlier, if you have any gray area, please don't hesitate to use the comment section. We'll be glad to respond to your questions. Thank you for staying with us, and do have a nice time.